Hello, welcome to this video where we shall be talking about exponents, okay? So exponents is one topic under algebra that just works based on the laws, okay? They are more like rules that one must follow for you to answer questions that are related to the exponents, okay? So let's start by looking at the different laws of exponents, okay? Law number one is usually called the multiplication law, okay? So in this law, we say that if you're multiplying numbers that have the same basis, so before we even get to the, can we really explain what a base is, what is what? So if you have, let's say, something like maybe 2a to the 5, okay? So we know that this a is going to be called the base. So in other words, a number that is raised to another number. The number that has something raised on top of it is what is called the base, okay? Because holding that exponent. So this 5 becomes the exponent, and then this 2 becomes the coefficient. Okay, now the combination of the base and the exponent is what we call the power. Okay, some people confuse the exponent with power. It's not the same thing. So a is the base, 5 is the exponent, and then the combination of 5 and 8 becomes the power. Now, we said law number one is about the multiplication of the bases. So if the bases are the same and we are multiplying, we can as well just add up the exponents, okay? That is what this law is telling us. An example, x to the 10 and x to the 2 is just add up. You have x to the 12 as our answer. Second law is the division of bases or exponents. So x to the m divided by x to the n. So when you're dividing numbers with the same bases, we subtract the exponents, okay? Just like that. X to the 78 divided by x to the 8, the same as x to the 70, just as the answer is straightforward, okay? Then law number 3, it's about an exponent of an exponent. So in other words, we have an exponent that is raised to another exponent. So in this case, you just have to multiply these two, m and q. You get mq. Okay, so that will be our answer. So the same is correct when you're dividing. Okay, but let's first deal with the multiplication. So 4, x to the 4 and then to the 10, that's going to be 4 times 10, which must give us a 40. If you have x over y to the m, and then everything is to the q, this m and the q must multiply. The exponents must always multiply each other. Okay, so x over y to the mq. And then this mq now must distribute itself. It must affect the x. It must also affect the y. It doesn't affect only x. It must affect both x and the y. So depending on what exponent was here. So if let's say we had a 2 there, then the 2 will multiply with the mq. And then whatever exponent is raised to the y must also multiply with the mq. An example, we have x over y to the 23. So 23 is raised to the x is raised to the 23, and then y is also raised to the 23, and then that will be our answer. And the opposite is true. In other words, we can move forward, and then we can also move backwards. What this means is that if we're given a question like maybe x to the m minus n, you can also write it as x to the m divided by x to the n. Something like that. That's what I mean by it can flip backwards using the laws. Then law number 4, we are multiplying this with another exponent. Again, it's just links to the previous law. So this q affects the w, this q affects the 12, and then we have it like that. X to the 3 times y to the 5 to the 10. So this 10 affects the 3, so it's going to be 3 times 10, which is a 30, 5 times 10, which is a 50. All right. So that is how we work out that. Then they're giving you an example of 12 to the exponent of 4. So 12 is not a prime number. And in most cases, if we have solid big numbers that are not yet prime, we are always advised to express these in terms of prime numbers. So which will be like 4 times a 3, but 4 is not a prime number, so we can use 2, which is like 2 squared times a 3. Now we are raising everything to the 4. Then multiply that. So 2 to the that is going to be 2 to the 8 times 3 to the 4. Then you can go ahead and simplify that, okay? So that is how law number 4 operates, okay? Then those are basically the only laws that we're going to focus on. In as much as these definitions are also termed as laws at some point or with some context, but I'll prefer calling them definitions, okay? So if we have x to the power of n, the meaning of this in under the SARS is all the powers, like we are multiplying that number, the number of times the exponent dictates. If we have x to the 7, it's like we are multiplying x 7 times, okay? That is definition 1. Definition 2, anything that is raised to the exponent of 0 must always give us a 1, even if it's a bracket, just like here. The answer must always be a 1. So 5 to the 0 is a 1, 3 that is a 1, and okay, so however big a number can be, as long as its exponent is a 0, it's as good as having just a 1. So alternatively, in equations, especially when you're talking about exponential equations, you could be given a 1. So this one can represent a variety of bases to the exponent of 0. It could be 17 to the 0, 5 to the 0, 7 to the 0, 16 to the 0, and so on and so forth, okay? So just pay attention to that. Then definition number 3, any number that is raised to a negative exponent can be expressed to a positive exponent when you switch its position. So this is like a to the negative a over 1. Just switch the positions. So the 1 goes on top, the a comes down, and then the exponent will become positive. If it was initially negative at the bottom, then switch it and take it on top, it will become positive. So that's how the power or the definition of negative exponents operate. So x to the negative 12 is the same as 1 over x to the 12. 4y to the negative 7 is the same as 4 over 7. Why are we not taking the 4 down? Because this negative 7 is only affecting the y and not the 4. 4 is the coefficient. All right, so that is what happens with that. They're giving you the do's and the don'ts, negative exponents, and so on and so forth. Okay, as you can see. Then let's look at some applications or some questions in particular that we can look at. Now, when you're dealing with exponents or questions that have exponents in them, remember how fractions operate, okay? Because sometimes you'll be given plus signs or minus signs, and there's something tricky that we shall also discuss if we can get a question of that nature. Then know how you cancel things out and the numerators and denominators. So like the first one, it's multiplication and then division. So let's deal with the coefficients first. So what is 6 times 2? That's going to be 12. And then these bases are the same. So x and x. So we shall have to plus the exponents. So that's going to be x to the negative 1 over, this is 8x to the negative 3. Now, I have 12, I have 8. I can divide this by 4. I'm going to get a 2. By 4, I'm going to get a 3. Okay, so which means I have 3 over 2 as my coefficient. Between negative 3 and negative 1, I can see that negative 1 is bigger. So which means I have to subtract from the top. It's going to be negative 1 minus 3, which means I'm going to get an answer of a 2. So x squared becomes my answer. And then part B, we have 4 to the x minus 2 times 9 to the x plus 1 over 3 to the x minus 1 times 12 to the x minus 1. So in this case, where the bases are not prime numbers, please just change them into prime numbers so that we can easily simplify them. So we know that 4 can be written as 2 squared. You know? So I'll say 2 squared, and then the exponent is x minus 2, times 9 can be written as 3 squared with the exponent of x plus 1. I'm dividing this by 3 is already simplified, so I cannot go down there. Then 12 is going to be 2 squared and then a 3. So it's going to be 2 squared times a 3. Everything is raised to the exponent of x minus 1. All right. Then I need to open up the brackets nicely. Let's open the brackets. So that's going to be 2 to the exponent of 2x minus 4 multiplied by 3 to the exponent of 2x plus 2. Then this is divided by, it's going to be 3x minus 1 multiplied by, now this 2 will affect this whole thing. Okay, so that's going to be 2 to the 2x minus 2 multiplied by 3 to the x minus 1. Okay, so we're done with the splitting of everything. What is left is now to apply the laws. This is the other law, whereby if you're dividing, you subtract the exponents, and if you're multiplying, you shall do the addition of the exponents. All right, so what I'm going to do from there is let me apply the laws at once. Okay, so if I have, let's say 2, I'll use the long way because people get lost with the short way. I have 2x minus 4, but then I'm working on this, so which means I'm going to subtract since this is a division of the 2's. So minus, I'll use a bracket. This is 2x minus 2. Then times, I have 3. That's going to be 2x plus 2. And then I subtract this whole thing because this and this will be 2 of them, okay? So I'll say minus x minus 1, then minus x minus 1. All right, then when I open the brackets nicely and neatly, that's going to be 2. This is going to be 2x, that's going to be 2x, gone. Then this negative and negative will give me a positive, so which means I'll be left with 2 to the negative 2. When I look at the 3's, this is a 2x, it's a negative x, that's a negative x. Okay, then I'm going to be left with the 1 and the 1, which is a 2 plus 2, which is a 4, 3 to the 4. But I know that 2 to the negative 2 can be changed into a positive by making this a denominator. So I'll be left with the 3 to the 4 over 2 to the 2, something like that. And then I can go on and simplify that. I can just punch that into the calculator because I know that 3 to the 4 is going to be 3 and 3 is 9, 9 and 9, which is going to be like 81 over 4. This becomes my answer. So this question, 5 marks wouldn't be that bad. 5 marks. So that's how we would have approached this. So we use what we call the prime factors. Whenever you have bases that are not prime numbers, apply the prime factors and then do the subtraction. So in cases whereby the exponent is more than one term, just like here, x minus 1, 2x minus 2, and so on, apply the bracket first when you're subtracting so that the negative can affect everything that is within the brackets. All right, Patsy, we have 2 squared times 3. Okay, over 2 to the 2a times 3 to the a. What's going on here? What is going on here? Okay, I can see the answer could be maybe 12, I don't know. But it's what I'm smelling or what I'm thinking. Let's see, there are 2 ways of doing this, okay? The first one, which is more or less the long way, could be for you to introduce this into. Like I said, that is a bit long, but we have to go that way first. So 2, this 2 times a is going to be 2a. The 2 times 1 is going to be a plus 2. Then times 3, that's going to be a plus 1 over, this is 2 to the 2a times 3 to the a. When I apply my laws, I'll have to subtract. So it's going to be 2a plus 2 minus 2a into 3a plus 1 minus a. So the 2 and the 2a will cancel. I have 4 because 2 squared is 4. And then the a and the a will cancel. I'll be left with just a 3. And then what is 4 times 3? It's 12. I told you, okay? All right, so let me see what the quicker way would have been if you really saw what is happening. So with the quickest way, what I'm going to do is I'm going to ignore the first part, the numerator, and only focus on the denominator. So I'll leave the numerator the way it is. or I'll even simplify it further. I don't care. You know that 2 squared is going to be a 4. A 4 times 3, that's going to be a 12. But before I get there, let me leave it there like the way it is. I'll have a plus 1. When I come down, I have exponent a and exponent a. I need to pull the exponent a out. So it's going to be like 2 squared times a 3 to the exponent of a. You see? Now we have the same bases, okay? The bases are the same and we are dividing, we subtract. So this a is going to minus that a and we shall be left with a 1. So we know that 2 squared is a 4 times a 3, which is a 12. Okay, 12 to the a plus 1 over 12 to the a. And the answer is just going to be 12. All right, so there we go. Paddy. We have 2 to the 3 into x plus 1 over the square root of 64 to the x. Like, really? What's going on here? All right, let's make sense out of this whole thing, okay? Let's open up the bracket. So it's going to be 2 to the 3x plus 3 over, we know that 64 is the same as 2 to the 6, no? So that's going to be like square root of 2 to the 6x. Okay? Then whenever we are finding the square root, we divide the exponent by a half. Okay? Divide the exponent by a half. So this is going to be the same as 2 to the 3x plus 3 over 2. When we get 6x divided by 2, it's going to give us 3x. And then we subtract. The bases are the same, do the subtraction. So it's 2 to the 3x plus 3 minus 3x. We're left with just 2 to the 3, which gives us 8. This is more or less the long way, okay? Someone will say, now, what is the short way? What is the short way? So the short way would have been to, but it's fine. Let's go with this one. I don't want to confuse people. So guys, let's stop there for now. Let's meet again when you're dealing with equations. For people that have not yet subscribed, please do subscribe so that you do not miss out on more videos that will be coming ahead. Bye-bye.